Hi, everyone. So excited to be here today with Nathan from our Discord community. Today, Nathan's going to be giving us a talk called Intro to Art for Programmers. And as you know, this month of August is Replit Creates here at Replit, where we're giving you a new prompt every day to create something beautiful or terrible or annoying. We'll see kind of how the prompts go. Today's prompt is write a story. So excited to see what you have for that. Yeah, Nathan, you want to take it away?
So thank you all for coming out. This is my presentation on Introduction to Art for Programmers. I guess we'll just start off by introducing myself. So I'm a rising senior at Del Oro High School. I'm primarily experienced with React and Next. So I guess you can consider me like a Jamstack developer. And within like the creative coding landscape, I'd say like around like the intermediate stage. So we're not going to be covering like more advanced topics like shaders, but we are going to cover like what creative coding is, what my thought process looks like, some example sketches, and where you can go from here. So this is just me and my chicken on the right. So what exactly is creative coding? I think it's an ambiguous term. All of us have some kind of intuitive definition of what it is. I think the most simple term is just like, well, it's just art that you made with a computer or art with code. But I think you can define that a little bit better. The book, I think the book, A Practical Introduction to Processing, best defines this as a merge between the mechanical and the organic. The mechanical being like the algorithmic side of things, and the organic being the fluidity and expressiveness of art. So even I think nature also represents this because nature has a sort of structure to it. It has repeating patterns, but it's not completely organized. There's some randomized chaos in there. And that's why I think nature is a primary target for creative coding art. I think creative coding also applies to all sorts of audiences. Not only is it a great way to get into programming because it's a very visual introduction, but it's another way to get a fresh perspective on programming and what you can do with it because art is typically not considered when we make some pieces of software. We're usually focused on functional things, not so much on how can we make this evoke feelings from a user. So on the right, we just have a very generic fractal tree, and that's like an example of how you could represent nature through code. I think a lot of the times art pieces are called sketches, and that was sort of popularized by processing. And I just want to showcase how they can have practical applications beyond just being art pieces. So one of them is advocacy. So on the right here, we have a sketch that I was actually commissioned to make by the Creative Reaction Lab to represent the situation with Roe v. Wade. So you can kind of see how I like some of the choices that are made to represent this decision, but you can see how is art is not necessarily just about making something that looks cool. It's also about making some kind of message and having a story to tell. So that might be something to consider when you look at today's prompts. Beyond that, you might have something to do with visualizations. So typically people with Python might use like matplotlib, but those are more functional graphs. They're not necessarily intuitive or great to look at. So that's another application. There's also another common application with immersive web design. And I like to showcase there's actually I guess you could say an artist by the name of Bruno Simon. And he has his website. I'm sure many of you have seen it, where his website is like a game where you can load in a car and play around with that world. So creative coding has a lot of applications. There's also NFTs, but I don't really talk about them too much because a lot of people in the Discord community don't really like them. But I think it's important to recognize that NFTs are another way for artists to make money off of their work. The creative thought process, I think you really need to find this for yourself. But personally, I have an app called Concepts on my iPad, and it's sort of like an infinite canvas where you can just sketch things out and write your ideas. So I highly recommend that if you're looking for something or some kind of tool so you can brainstorm your ideas. So I particularly like this app because of its infinite canvas. But if you're struggling to come up with ideas, you should really ask yourself the question, what if? So for example, on the right, we have an asteroid that's sort of like plummeting from the sky, so you can ask yourself, what if instead of a randomly generated polygon, we try like randomly generated circles instead? So what if is a really useful question to ask yourself if you're trying to make more variations off an existing sketch. But if you don't have any ideas, you can actually go onto Twitter, and there's a lot of hashtags on there where you can see what generative artists are doing. So one of them is generative art, I believe, and you can see that there's a lot of interesting art pieces. For example, this one, and this is like super complicated, and we're not going to be able to make that in today's tutorial. But you can see you can get inspiration from the type of themes that they use. You can even recreate some of their work as a form of practice. And I actually highly recommend that you recreate some modern art as a form of practice because modern art typically isn't that complicated. So this is just an example from Damien Hirst where he just makes a bunch of polka dots. And we're actually going to be able to recreate that today. I also highly recommend that you balance tutorials with exploration. So I know there's a lot of resources out there, for example, books and videos, but you really should be balancing that with creating your own sketches so you learn how to implement these creative tools with your own work. If all you do is copy from the web, you might find yourself in what many refer to as like tutorial hell. So you might want to use this question, what if, to make variations of what you learned so you can create your own unique sketches and your own spin-offs. So this is just like the implementation of the sketch that I showed you earlier, where we have the randomly generated polygon and the trails that sort of emerge from it. This is actually one of like my first animated pieces as well. So I just found that to be pretty interesting. In terms of technology, creative coding and the creative coding landscape, I think P5.js and processing, which is for Java, are frequently chosen because they're extremely accessible and they have like very high levels of abstraction, meaning like the API that they have is very simple. And just to showcase how like how committed they are to accessibility, like I just came across this discussion. I know that it happened like a long time ago, but they wanted to add the describe function to basically make it so people who are visually impaired can still appreciate sketches that are made with P5. So you can see how committed they are to making things more accessible, as well as reducing the barrier to programming and art in general. Another library that you can use, it just there's a lot of libraries out there that you can use to sort of offload the complex things to something like Matter.js for physics. And Matter.js is like is a very great physics engine. And I want to showcase just a very simple sketch that you can make. So if I go to, I'm going to go to Replit, and I have a Matter.js clock that sort of showcases this best because I don't actually know if like physics myself. I don't really know how to resolve collisions in code. So you can offload that to another library so you can like create things yourself faster. For example, this is the Matter.js clock. And if we open this up, you'll see that so we have like the hours, the minutes, and then the seconds in the center. But as opposed to just like learning circle packing or like learning how can I attract all these objects into the center, you might want to leave this up to a library so you can implement your ideas faster. And that's why making generative systems actually doesn't require a whole lot of advanced math and programming skills because when you can't make that idea yourself, you might consider using another library on top of P5 to help you make those sketches. Of course, I think having some level of math and some level of programming skills is going to help because the complexity in math is frequently showcased in art, and you can actually see that more easily. Aside from P5, I also just want to draw some attention to like how machine learning has some kind of impact in this space because I think a lot of you are probably familiar with this where you can just ask a machine to create art for you. And this is one of many things you can do. You can just ask it to create art and it'll make art. So this raises a lot of interesting questions like who actually gets credited with this, but you could also see how this might accelerate certain workflows even if you're just an artist. For example, let's say keying out certain frames or retexturing certain objects, you can ask AI to help do that for you. So we're actually going to take a step back and we're going to actually go with the code because the code is all really what we care about. So we're going to create a couple things. We're going to create polka dots, which I kind of alluded to earlier, and then learn how we can center that into a grid. I know that centering a div is like a common joke with front end, but it's actually not that hard for canvases. We're also going to be looking at randomly generating lines and how that can impact certain features, and then how we can use a webcam to process how we can process webcam data to make an interesting filter. So the first one is polka dots. So censoring a grid uh, is not that hard, and we're going to create this basically. Now that might not look that complicated, but we're introducing a lot of topics here, including what a P5.js canvas looks like, as well as how you can create this grid and center it. So I'm going to go back to Replit and make a new rep. Actually, I have a template here called a P5JS template, and we're going to make a fork of that. If we make a fork here, and we can call this polka dots.
Adding myself back in so I can ask questions. Cool. Did you make this template?
Yeah, so like this template is on my profile, so you would be able to find it. But I know that Replit has like its own template. I'm just using this one because I added like just like getting random colors, which I'll talk about in a little bit.
Awesome.
Okay, so I just want to like quickly just like talk about the anatomy of a sketch. So usually with at least with uh P5 and processing, you have something called setup, which like initializes everything, and then you have a function called draw, which actually like is like the animation loop. It actually draws stuff to the screen. But you could also draw stuff in setup if you're making like a static sketch, which is what we're going to do. So I think I might just like make this public. You could probably just like this is like a join link, and you guys can just hop on and see what I'm doing. Uh, I assume I could just put that in there, but
Yeah, I can send that to everyone.
yeah. So we have the setup function, we have the draw function, and then I just want to talk about this fetch colors function, which is not like native to P5. I just made that myself. And basically, I'm getting random colors from this thing called Nice Color Palettes. And you might just look that up like on GitHub or on NPM, but they just provide like a bunch of JSON files with color palettes in there, which are pretty interesting and pretty useful. So that's what we're doing right here. We're getting randomized colors from this fetch colors palette. First things first, we create the canvas, and then we're going to talk about creating a grid of circles. So let's get rid of the draw function because this is a static sketch. So we're going to comment that out. And in order to make a grid, we're going to need a nested loop. So if we say like for let x equals 0 and let x is less than 10, let's say, and then we do the same for y.
So Nathan, for the draw, sorry, I'm hearing a little bit of an echo. I think it's better now. For the draw function, isn't it true that the draw function will like run every certain amount of time interval? Do you know what the time interval is? Like it's basically a while loop that goes on forever, right?
Right. I think the implementation probably differs a little bit from just a while loop, but basically it's run around 60 frames per second. It's not really like exactly 50 frames per second because you actually need to like you have to set that yourself. It also depends on the machine. Okay, I
Wait,
guess we
no.
have somebody that wants to delete everything, but uh well, I mean, I could just write that back. Let's I'm gonna do myself a favor and just make it a new one. But anyway,
Yeah,
so the draw function
just
is called like
and
roughly.
not,
It's roughly
but
yeah. It's
it's
roughly
not.
60 frames a second. It's not exactly called that many times, but I'm just gonna make a new fork. I guess you guys could just play around with whatever that is. But so we have a new template, and I discussed like I discussed these setup and draw, and we're gonna rewrite that for loop back in. Less than 10 x plus plus, and then we can write another for loop. This will give us the x and y necessary to make that grid. And you might notice that we're reusing 10 here, and this is going to be like the size of our grid, so we might as well just store that in a variable. Let's just call that size, and we can stick that back in there. Because this is like a global variable that kind of configures the entire sketch, we might want to just keep that on the top with everything else. And this is actually pretty simple. We just say circle at x and y with a radius of 10. So you can see how P5JS is pretty simple. Oh, I forgot to remove draw. But you can see how this is P5JS is really simple to use. And you'll notice that all these circles are kind of crammed up in the top left of the screen. And that's because this X and Y is between 0 and 10. And you can kind of tell that those are very small numbers and they're all kind of just like crammed up in there. And you can change that by changing, like say, instead of size of 10, you could say like maybe you change size to the width and then make X like increment by a certain amount for the spacing. But there's an easier way to do that. You can actually map the X and the Y to an entire new range of numbers that'll center that for you. So there's a function in P5 called map that you can map this X value, which will be between a range between 0 and size. It actually is size minus 1 because you notice that we're doing X is less than size. And then we can map that to an entire new range of, let's say, 0 and width. We can do the same with y. So if we say map, if we map the y between 0, size minus 1, 0, and height, and I'll just depend on Replit's code formatter to fix that for me. But so now we have an entire grid where the circles are evenly spaced out, and
Wow.
it's we don't really want stuff like clipping in the corner. So we can,
Yeah.
instead of mapping directly between a 0 and a width, we can add a margin in there. So let's say we add a margin of like 30, uh, and we can map between the margin and then the width minus that margin. So let's just minimize that a little bit.
So are you just making like global variables then for those types of things like size and margin so that you can easily adjust them until it
Right.
looks you want it to look?
Yeah, and in P5, I know there's like sliders that you can use to sort of manipulate these, but I just keep all of the things that manipulate the sketch globally, like at the very top. So you can just change those and have fun with that. But so now we have all of the, like, I guess, polka dots in the center of the grid, and they're not being clipped on the side. And we actually, maybe we want like less of them, so maybe we just like change that to 7 because maybe there's too much, there's too many of them. All right, so we want to be able to change the color of these polka dots. So like, like right here, you can see that there's like a lot of different colors, and we can do that by saying fill. So that's like, this will change the fill color of that circle. And if we use random again on the palette, we'll get random colors that come out. So we get all these random colors, but we also have like this nasty border on the outside that we kind of want to get rid of. So if that's called a stroke, and if we say no stroke, then it completely gets rid of that. And we can make the radius of these circles even bigger. So let's make a new variable called radius and call it maybe like 20, radius of 20. And that should, yeah, that should make them a lot bigger. And maybe you want them even bigger than that. So even 30. And I think this is not actually technically right because in P5, they don't actually take radius. This is like the diameter. So I guess technically you would have to do like times 2 here and then make that 15. But it doesn't really matter because you just want to make something that looks good. All right. And then I kind of forgot about the background. So let's add the background back in. All right. So if we reload this, now we'll see this is like the polka dots. And this is basically modern art. That's it's pretty simple,
Wow,
but
that is exactly like the day manager.
I know it is pretty simple. And we can add more margins to that. And you can play around with this in the future. So this will give you the tools necessary to sort of draw stuff on the canvas and then getting these random color palettes. And we're just going to move on to the next sketch where I'm going to show you how you can make like a lot of lines and then sort of overlay them in a certain pattern. So that's the next sketch.
Awesome. Nathan, will you publish these to community? You don't have to do it now, but maybe after so we can put them in the description for folks who are doing it afterwards.
For sure. Yeah,
And
so
then
I'll publish this later, and then for now, if you just want to see it, just go to my profile on Replit, and you should just be able to see this.
awesome.
Okay, so we're gonna go on to the next set of sketches. So this is the next sketch we're gonna make. It also is kind of in the same vein of modern art, where you just have like these random lines that are kind of just like skewed all over the place, but they're in a circular pattern. So we're gonna go back to our P5JS template and make a fork of that. So this sketch actually isn't going to be static. We want to keep adding like lines to this thing, like every frame. And so we're going to keep the draw function, but we're going to remove background from there because that'll clear everything and move it back up to the setup function. I think this is a good point where we talk about polar coordinates. So this is polar, like these are polar coordinates, right? So generating stuff in a circle, which is like what we're doing here, is actually pretty hard if you consider that you like, let's say you want an x and a y, and like you just generate a random x and a y. It's chances are it's not going to end up being on the circle. So another way of thinking about this is, what if we use a randomized angle to a certain radius, and we can just get that whatever that coordinate is, and then the trick will be converting a polar coordinate to a Cartesian coordinate. So this is where we can use sort of a little bit of trig and a little bit of math to extend our sketches. So if we get a random angle, let's say 30 degrees, and we have a radius of 3, how do we convert that into a Cartesian coordinate? And it's pretty easy actually, because you can draw a triangle here like if you drew a triangle right here, you would notice that you could use like SOHCAHTOA to essentially get the x and y. And the y would be like sine of theta times the radius, and the x would be cosine of theta times the radius. And
Wow,
that's
I haven't
exactly what
heard
we're gonna do.
Sokotoa in ages.
Yeah. So we can use that to like effectively create random points on a circle. So if we make a new function called maybe like draw or generate point, we can just come up with a random angle. So let's say the angle is a random number between 0 and 2 pi. And let's actually make a radius as well, because this is going to be the radius of our circle. So let's say the radius is like 200. And generating a new point is really as simple as saying like sine. So for the x, it was cosine of angle, and then times the radius. And then for the y, it was cosine of sine of angle, my bad, sine of angle times the radius. So now we can just say like point A on the circle is generate point, and then point B on the circle is generate point. And then now that we have 2 points, we can just draw a line between them. So if we say line between A and X, so A dot X and A dot Y to B dot X and B dot Y, we should get a bunch of lines that are sort of appearing in a circle. And you'll notice that they're all kind of being generated up here. And that's because we're assuming that the origin is at like 0, 0, which in P5, that means that it's going to spawn stuff in the top left of the canvas. So we can actually fix that by using just a very simple trick. If we just translate everything to half of the screen and half of the height, then we're actually going to just move everything to the center. So that's like a very neat trick that you can use to just translate stuff where you need it to be without directly modifying those components yourself.
Mhm.
And if we leave this, it's actually going to create like a sort of shaded sphere. And this by itself is actually kind of like a cool sketch. It kind of reminds me of like the Brilliant logo, if you've ever seen it. But we can modify this even
That's
further by
very
getting, yeah, so we can change this even further by just adding random colors to this. I mean, this by itself, you could just like, it's perfectly fine. But in order to extend this a little further, let's just get random colors. And if you recall earlier, we get a random color by just saying random palette. And we can just say stroke, which will change the color or the stroke of the lines that we're making. So it's going to pick a random color from our color palette. So let's just see that in the full window. So this looks pretty cool on its own, but maybe you don't want like all these lines to be generating. Like maybe you just want like a couple lines, like well, let's say only 75. And one way you could sort of limit that is say, let's have a counter. So like count it, or how about, yeah, a counter, and then we'll have like a max counter. So that would be like a maximum number of lines. So let's say that max count is uh, maybe like 100 or 75 or whatever you want this maximum number to be.
Did you
But
talk about fetch colors yet?
I think I did, but let's just go over that. I know I kind of just said that I'm fetching colors here, but let me just open this up in a new tab. So you can see that these are like a bunch of color palettes that are just stored in JSON format. And essentially what we're doing here is we use fetch, which is part of like, I guess it's just part of like the browser now these days. And you can fetch that URL and then we load that into a JSON format and we just save that into this array.
Wow,
Basically,
that's a really cool tip. I feel like people can use this file to do a lot of really cool stuff because you're using it in all of the examples, right?
right.
To randomize colors. Isn't there also a like random number generator built into processing or built into P5?
Yeah, I've been kind of like talking about that a little bit. Like I've kind of been alluding to it, but P5 offers like a bunch of functions, and one of them is random. So if I just say random,
Yeah.
like in this like bottom left, you'll see that it just generates a random number, and you could like mathematically generate colors. I just found that having like a preset defined like color palette that people have actually made. Because like if you go to nice color palettes, I think they scrape these from a website of sorts, and then they came up with all these color palettes. And usually the ones that people make are a lot better than the ones that just algorithms just randomly generate. So that's
Yeah.
why I'm using those.
I mean, it looks great. It's very aesthetically pleasing every time it comes up, even though it's like a new set of colors. That's awesome.
Right. Yeah. So back to right here while we were just talking about count. But basically, every time we like do this draw loop, we could say like we can increment the count, and then we could just check if the count is like greater than the max count. We can just exit draw early, and that'll prevent us from adding new lines. Because right here we're adding new lines, and we can just prevent that from happening once we reach like a certain count. So if we go back to like the sketch, you'll see it'll keep adding lines. Let's get a different color palette, but you can see it'll just keep adding lines, and then it'll just stop. So it'll stop at 100 different lines, and maybe that's the effect you're going for. You don't want like the kind of sketch feel, where it's like it looks like someone like was shading stuff in. Maybe you just want it to be lines like this. All right. So then the final sketch that we're gonna work on is, well, if we have more time, we could go to other sketches, but we're going to talk about how we can process data in order to make our sketches look different.
Can I
So this
ask
is
one more
the
question really quick
sure.
on the other sketch? Is there a way, like, so go back to that one. So, you see how they're or like go to the image of it or the when it's running. Yeah, so you see how the like lines are not um uniformly distributed, I guess. Like they're randomly kind of created, and so like it looks on the side like the left side is a little bit more condensed with lines than the right side. Is there some math you could do to like make it uniform if you wanted to?
Yeah, I think you would actually use something very similar to the grid that we were making earlier. So if you look at this, I think we could actually modify this so that the points of that grid could be used to generate lines, and then you'd have like lines just go across. And then as opposed to, I think rather than generating that grid as a circle, there's actually a function called clip in P5, in P5 that'll allow you to like sort of clip out certain regions that you don't want, and that'll allow you to just like make it look like a circle even though it's not. But that's like I think that's one way you could do it, where instead of having stuff like sort of clumps up like this, you could have it like sort of generate into a grid that you want.
Cool. Yeah, I mean, I get that part of it is that we want it to be random because that's what makes it a bit more interesting, but I'm just asking in case anyone wants to make something like perfectly like uniform.
Right. Yeah, so that's something you could play around with. I know right now that we're just kind of, well, you could actually create certain types of lines as well. Like, for example, I think if you just want like straight lines as opposed to these kind of lines, I think you might be able to modify this where we use like the same x value on each of them. So you should be getting like, yeah, we should be getting like straight vertical lines. They won't necessarily be like in a full circle, but here, let's just remove max. Let's make max count like a lot bigger. But you can make like certain types of lines if you only use one component of the, yeah, if you only use like one component of the generated line function, you might get something like this. And you could use clip again to get rid of like this part right here, or check maybe if the y actually goes on somewhere on the circle. But you can make a lot of variations here with very simple tools, and you could like save these as like an entire new sketch.
That is very cool. Wow. You're right. The colors are really nice. That
Yeah.
function or that file is really helpful.
Okay. So I think that's also like another good point to make is that when you have ideas, you should also just write them down, because a lot of people think that you'd be able to remember them, but you should really be writing them down because you might forget. And that applies to variations as well. So if you like certain variations that you're making, for example, those vertical lines, you might consider just writing that down like in the comments where you can change the sketch into something entirely different. And then you could revisit that back later to make an entirely new generative system. It doesn't really matter. But so that's something you could do. Uh, let's go back to the slides, and we're gonna just create like a webcam that effectively looks like this, and it's gonna be like animated, so it'll actually be moving.
Ooh.
So if we go to, let's just close a little bit of these tabs. I'm just gonna show you what we're gonna be making because this is gonna be a little bit more complex than the other ones. So it'll look very similar to this, where we have a webcam, and it like sort of maps like the colors to the actual webcam. I think this one might be a little like, I think it might be like squishing the image a little bit, but you can kind of see how like it kind of has this painting effect and it draws like the screen.
That's awesome. It reminds me of like photo booth. Like, did you ever play with photo booth?
I mean, no, not really, but yeah,
That
it's
might
kind of
be
like a filter.
my generation, but there were like all these like effects you could put on photo booth, like on your Mac computer, and like we would hang out with our friends and just take like funny photos on photo booth and do all the like different effects on them. It reminds me of that.
Yeah, so if we go, I think, yeah, so we're gonna make a new template again. We're gonna go back to the template and just fork that. And this is actually P5 offers a lot of tools, so things are not actually that complicated. For example, if we want to get that webcam data, we could just make a new capture, and that's what it's called. So say the webcam is capture, and if we just say capture equals create capture video, this will actually just make a webcam capture for us. We could also set the width and the height to be the same thing as like the canvas. So if we say like capture.size, I think width and height, that should make it so it's the same like width and height. You might actually have to play around with this because different webcams have like different aspect ratios. So that's why mine was looking a little bit squished. And so we can see the capture at the bottom here if you see this. And we want to be able to take the data from this webcam and sort of put that onto the canvas because we can't really do anything with a video element. If I inspect this, you can see that that's just a video and it's recording like my the webcam, but we can't manipulate those pixels to make something cooler. So let's go ahead and actually hide that. We don't need to see the capture, right? Like while we're making this, we can just say capture.hide. And now when we look at this, we just have our canvas. And basically in the thing, is this very similar to the line sketch, except instead of the colors being randomly picked, we're making those colors depend on the webcam itself. So I just want to quickly show you how you can draw like the webcam contents onto the screen. There's a function called image, which will allow you to do that. If we say image capture, and then in image will actually take a couple of parameters. So after like the capture, which is the actual image, we have to pass in the location. So we want that to start in like the top left, so 0, 0. And then we want it to be the full height and width of the canvas. So that's the next parameters. And it's pretty self-explanatory, but you can see, and this will be able to just render the canvas or the image of the webcam to the canvas. And you can see this is a little squished. So we can change like I guess the aspect ratio of our canvas by say making the width 800 and then the height like 400, and that should help like make it less warped. Actually, that's a little too warped, but so we can play around with that a little bit more. There might be a way to actually get like the webcam dimensions, like what your system actually uses. But I think just finding what works for you, like just randomly guessing, it is like a good way to just figure this out. So now we have the webcam, but that doesn't look like very interesting. We want circles to sort of appear on the screen that renders out this image. So if we go back to draw, we can comment out this image function, which will just draw capture to the canvas. So we can comment that out. And we want to just generate random circles. So like we did in the line, I think in the, let's go back to lines. If we look at, the sketch that we did previously, basically every draw loop, we're just adding a new line to the screen, and we're going to do something very similar. And instead of adding lines, we're just going to add circles. So we say like circle at, we want to save like the X and the Y. So let's say the X is a random number between 0 and the width of the screen, and say Y is a random number between 0 and the height of the screen. Then we can just draw a circle there. Let's say also a random radius. Let's say a random 10 and 20, something like that. So this should give us like a bunch of random circles on the screen. And the trick will be just getting those circles to have the same color as the webcam.
Like even that is really cool. It kind of looks like bubbles, and you can experiment with like, colors and sizes to make something really cool and generative just from that. That's what I
Yeah, I
love
mean,
about it.
this by itself is kind of like a generative system. Like you could keep this as like a whole nother art piece. If we
Awesome.
let's also get rid of the stroke because we don't really want the border, and you won't see anything now because like the fill is white, so you like everything's gone now. But let's fix that. So in order to get a pixel value, there's actually a function called get, and we're going to go over why this might be a bad idea because it's going to be very slow. But we have something called capture.get, and that'll get us the pixel value, like the color of the pixel at that location. So if we say fill and then we just say capture.get, we should get colored circles. But another thing I want to note is that I think capture.get might handle this for you, but you really want to be making sure that the x and y you pass into here are like integers because I think that an x and y with a float value might be confusing, especially when you look at the actual pixels array. Like you can't get indexes of like a float. Like you can't use float numbers as indexes. It just doesn't really work that way because everything is like an integer between 0 and the length of that array. But so now we're getting these random circles, and let's say we want to add like a lot of circles at one time. So we could actually add a loop for that. If we say like for let I equals 0, I is less than 100, because we want to add like 100 circles every time we make an animation loop. And if we just move this into there, you can see that this is like extremely slow. Even if I X out all these other tabs that are doing their own thing, like this is very slow. Like you won't be able to capture movement with this kind of setup because it's just too slow. And one way we can alleviate that is actually by using a different technique as opposed to using get. We want to be able to like instead of using capture.get, we want to like calculate this index ourselves, which is like a lot faster than whatever this is doing.
I
But I
feel
want
like
to
a good reminder here too is that all of this is happening in the draw function, which, as you said, is running like 60 times per second or something.
yeah, it's like 60, yeah, something like that. But like depending on what you do in that draw frame, it might like slow it down a lot. So it'll
Yeah.
try to get there, but it might not actually reach that.
Yeah.
One way we can accelerate this is by making instead of making our way of getting those pixel colors a lot more efficient. So if we say I just want to like quickly explain what the pixels array actually looks like. So you might think that pixels might be sort of like this. Let's say we have like a two-dimensional array, and then like we have pixels in here, and I'm making like a simplification here by using single numbers. But maybe this is your image. It's stored as an array of pixels, and each value here is like that intensity of the pixel. So in technicality, like right here would be like it would actually be another array in there, but we're not gonna we're just gonna ignore that. But basically, we have a width and a height, which is so the height being like the number of rows, and then the width being the length of each one of those rows. And then if we want to access one of those components in there, you could actually make a like just a very simple calculation where you say width times or y times width plus x. And why does that work? Like, why does this particular function work? It's because, well, every one of these rows we know will be the width of the the width of the capture, the width of the canvas. So we know that every one of these rows is going to be a size of width, and every row is like controlled by y. So if we get y times width, we're going to be getting one of these rows, like one of the indexes at that row. And then in order to like fine tune that, we need to add x. So now that we have the rows, then we can add an x to that where we can get like a single value in those rows. And the reason why we're doing it like this, as opposed to say like, how come you can't just do like capture.pixels and then use it like an actual 2D array? Like let's say we wanted to do like index y, index x. The reason why we can't do that is because processing or P5, they actually store pixels as like a one-dimensional array. So it doesn't look like this. Like this is what we anticipate, but it doesn't actually look like that. It looks like just a giant array of like random numbers. So that's what it's actually stored as. And we have to sort of make our own custom calculation here to make sure that we get the appropriate values at those pixels. So as I kind of like also said this earlier, but instead of zeros here, you might actually have like you'd be talking about like a lot of numbers in each one of these cells because a pixel is made of like four components. It's like it's RGB and then the alpha. So the red, green, blue, and then the opacity of that pixel. So we're talking about like a very long array, and that's part of the reason why capture.get was so slow. So we can do this ourselves. And one thing I just want to like quickly point out is like this is not accurate yet because I kind of talked about this right here. But like each one of these pixels is like it's 4 integers long. So we need to multiply by 4 so we can get that appropriate offset. And we can get the R value by saying capture.pixels index I. We could get the green by just doing one more than that. So capture.pixels I plus 1. And then we could get the blue by saying capture.pixels I plus 2. So that'll give us all of pixels that we need, or the values of the colors. And we can pass that into another P5 function called color, which will turn that into a color for us.
That's awesome. It's really smart the way that you're doing this, but it's also an interesting kind of note of the way that you have to maybe optimize your code differently when you're doing creative coding using P5 versus when you're trying to get the least amount of memory in like an algorithm or something, that you have to be even more creative when you're trying to figure out optimizations for this.
Yeah, it's really something to think about. I'm actually going to show you a sketch later on where it might be helpful to upgrade to something called shaders, which are more effective in terms of creating more interactive and 3D pieces. But so now we don't actually get anything, and that's because I forgot a special function that we need to call every frame. It's called capture.loadPixels, and load pixels is what actually enables us to get the pixels in each one of these. Like to actually get those pixels, we need to load them first. So we do capture.loadPixels.
We have a question too, Nathan. When you have a chance, put it up on the screen.
Okay. Yeah, I guess you could just ask that question because I kind of probably messed something up here. But
Someone's asking if P5JS is useful for interactive web pages, like a game or interactive art piece, or is it more for static pieces or animations?
well, P5 is really just like an all-purpose tool. I mean, anything that you can draw on a canvas, P5 is something that you would use. So that means you could use it for games, you could use it for interactive websites, you could really use it for anything. I know that it's mostly geared towards like these art pieces or sketches, as I call them, but you could really use it for anything. It's just a library that you can use, and depending on what you're trying to do, it might not be the best library for you, but in this case, it definitely is. It's not just for static pieces either. I know in the previous ones they were kind of like not moving, but this one will show you how. Well, I'm showing you how you can sort of integrate this draw function to make stuff actually move around.
Cool.
And I
Thank
think,
you.
and I think I figured out why this is not working. It's because I even told you guys myself, but you can't use float numbers uh, as an index. So we're gonna just like we're gonna make sure that those are integers. And I think yeah. So now it's actually working. And you can see how each one of these like pixels, I guess, is
Oh,
the value of that circle, and it gives you this kind of paint effect. And the next thing that we really want to do is actually making these pixels like we want to map those to a color in our color palette. So if I go back to these slides, you can see we have a very restricted color palette here, and that helps like make it feel more like a painting as opposed to just a random generative sketch. And that's partly because paintings, they don't have infinitely many colors to choose from. So even though this looks pretty good, we can make that even better by mapping like these colors to our color palette. So if we make a new function called maybe like closest color, we can use this function to then get like the closest color in our palette to the actual pixel value. So this closest color function is going to take R, G, and a B, and we can make like a new color called like maybe like the pixel color is like that R, G, and B. I just want to log like what does a color actually look like in P5. So if I go back up here and I just say closest color, let's say like 100, just a random color in there. So if I log this, you'll see that I'm missing. Okay, that's probably why I'm missing a comma. But so I don't know why I can't type. This is supposed to be console. Console. Okay. All right, so we have a color in here that P5 makes for us after we call the color function. And what we really care about is that in here, there's an array called levels, and levels stores like the RGB and as well as the A, but we don't really care about that right now. So it stores all the levels of the color, and we want to be able to use that somehow to like what's the distance between colors, and we could use this levels to help us find that. Now, like finding distances like is not technically accurate between colors. Like if you wanted to find, I know that a lot of people are probably familiar with the distance formula, like the square root of like delta y squared plus delta
Mhm.
x plus
Yeah.
on and on and on. So you probably are all familiar with that function, and we're going to actually use that. It's called Euclidean distance, but it's not necessarily accurate for colors because I don't believe colors are actually like especially with RGB, they don't actually reflect how they look like in to our eyes. So like a closest color in Euclidean distance not might be the actual like closest color in real life. That's just something to take note of. But for now, it's like good enough. It's good enough to just map our colors to a certain palette. So what we need to do is extract the levels here, and then it's like compute some kind of distance.
Got it. Nathan, as like a meta question, can you talk a little bit about how you use the developer tools inside of the browser to help you make art? Because I think it's interesting to watch you do that, and I don't really just kind of hearing your thought process on how you decide you want to do that or what you use it for would be helpful, I think.
Yeah, so like generally, I just use the console to see stuff that I'm not like familiar with because P5 like has a lot of built-in functions, and sometimes you want to see like what is it actually giving you, so then you can go and work with it. So like sometimes you just want to play around and see. So color, let's say you have a color here, and let's say you just want to see like what that returns with you. So I use the dev tools to kind of see and work around with the library. P5 is kind of hard. Like you can't like say like I want the X and Y of this of like a particular pixel on the screen. Like you can't do that in P5. That's
Right.
like not a thing in dev tools, but you can kind of like figure out what it's doing by like using some of these functions and then telling like P5 like, well, this is kind of what I'm looking for, and you can like read that, like you can see what it's giving you back.
Yeah, it seems like kind of an easy way to access maybe like documentation. Like obviously there's the official P5 documentation, but like if you're just trying to see what a function does or something like that, it'll give you the type signature and other things like that that may be helpful for figuring out how you want to write your code, right?
Right. And there's like I know there's like a lot of other like console.log. Like there's like things like console.table, there's like console.error. I mean like there's a lot of functions in the console that you could kind of use to help debug your code. I'm just using console.log because I just want to see what's in there. But like you might want to look into that if you want to like further debug your sketches.
Got it. Cool. That's awesome. I've never seen it used like that, so I was just curious.
All right. So one of the things I also want to talk about is that these color palettes, if I want also want to log the palette, but these color palettes are it's a string, like it's an array of strings. So if I log this again, you'll see that we have a bunch of like hex colors, uh, and that's not like the color representation we want. We want it to be in a form where we can access the levels, right? So we can fix that pretty easily by just using I guess like a functional thing that's like in JavaScript called map. And map will allow us to modify every element of that array. And we can just say like map C, and we just wrap it in color. So what this is basically doing is it takes every string, and maybe it'd be better if I just showed you, like if I logged every value to see, but map will basically loop through the array, and then you can make some kind of modification to that array. Or I think a better way to explain this is like we're mapping through this, and we're looping through the array, right? And we can make some kind of new change. For example, we make the string into a color. We can make some kind of new change, but it doesn't actually modify this array. And that's like one of the, I guess, key components of functional programming that you might want to also look into. But you can see, so right here, I'm calling map, and then I'm saying console.log. We want to log that color. You can see it logs each one of those colors in our color palette. And then if we log color palettes like in total, so that's what we do here, we get color representations in terms of P5.js. So we turned everything from a string into a color. And that's really useful because now we can access the levels inside of those colors without having to like do any fancy math ourselves and try to convert these hex numbers into like RGB values. P5 will just handle that for us. So we can use map to like loop through everything and then make those changes. So now that we have our color, so we have a pixel color and we have the palette color, we want to get like the closest distance, and we might actually want to use map again for that. So if we say palette.map, we're given a palette color out of that because we're looping through, and we want to get the distance between the palette color and the pixel color. And this will give us like a list of distances. You could write like the distance formula yourself, and I'm just going to do that just for the sake of just being for the sake of simplicity. So it would be like the math dot square root, and you would have to say like math dot pow or for like power, and then you would have to take like pixel dot color dot levels, and you would have to and then subtract that from the palette color levels. And you would have to basically copy this like as many times as you need to, so you have the full distance formula. So we basically we have to subtract between each of the levels, and if we treat all the levels as like some kind of coordinate, like I know that the distance formula mainly, like you might think of that as using just the coordinates. Actually, there's a good picture here, but you can see that we're taking the distances and then we're squaring them, and then we're taking the square root of all of that, and we just do that. We just replace the x and the y with the levels of our color, and that should give us the Euclidean distance between the colors. So if we change the levels, we want to increment these. So pixel.colors.levels and then 0, 1, 2. So this should give us a list of distances. So if we say console.log distances, and let's just see what that gives us. But so if we say closest color, and that should automatically log. So if we go back, distance is not defined. It's because it's not defined. So we'll add an S back in. Okay, so now we have the distances between each of the colors. And the next step is just going to be feeding this into our draw function and getting the smallest one. So this will give us the, if we go back, I just want to split screen for a second. If we go to our sketch and we look in here, so we're calling closest color 100, 100, 100, and we're getting the closest color in the palette, and we're just logging that to the console. So that's what we've done so far. But now we want to move this closest color into the draw function and then use the closest color instead of the actual value that's displayed here. So let's do that. In
I have
order
a
to find,
Nathan,
yeah,
with the have we implemented yet like to use the nice color palettes or not yet?
that's actually what we're doing now, because we want to get the closest color in the webcam to the palette. So this is I guess like all the stuff that we had before, like fetch colors. So we're actually getting random color palettes. We're just not seeing them yet, and that's what we're working on right now.
Oh, okay, yeah, because I was going to say these colors look pretty similar to the actual colors so far.
Right. So in order to get like I guess the index of the closest color, because if we go back to the console, we get this list of numbers, but we want to get like the index of the smallest one, so we know like that's the color to pick. So it's pretty easy if we just say like math.min. So math.min will give us the minimum value of this array. And then we want to do like index of, which will give us the index of the minimum. So if we say distances.index of, this will give us like the smallest distance. And I'm gonna log both of these so you guys can see it. So const minimum index. Let's just log both of those. So console.log distances min index. Okay, so that'll give us the, I'm not even calling them, but I guess we could just do closest color again, closest color. So this is just an example, 100, 100, 100. And we should see the index of the smallest value. I can't see. Should be distances. Okay. So now we're getting the smallest value, and it says that it doesn't exist. So I think probably because it might be an issue with floats, but we're just gonna see. If it is an issue with floats, we could just try flooring this. So if we say floor, but we want to return the color palette at that index. So color palette min index, and then back up here in draw, we just say, I think we could just call closest color on RGB, and it should be able to give us the appropriate color. And I've messed something up here somewhere, so I'm gonna quickly just try and debug this. And I think it might be because, let's just log distances again.
You have the working version on your profile too, right?
Right. So if you need to find that, it
With it.
actually is, there is like a working version.
Yeah.
Uh,
Live coding is hard. You're doing a great job.
I think okay, so math.min, I think I saw this earlier too. You see that it doesn't actually take an array. It takes like certain it takes like actual numbers. So we have to spread the values of that array into math.min, I believe. So let's try that. All right, so now it's actually working. So now it maps the colors of our webcam to the screen. And you could play around with that, but the I guess the one thing that makes like my previous example slightly different is that instead of using the actual color, it's using like it's adding a little bit of opacity as well. So then it gives like a little bit more of like an iterative painting feel. But you can change that as you will. But so that's the sketch, like pretty much done. So we have everything for this webcam sketch. And I would just want to quickly talk about before we end about how you can
That's so
extend
cool.
some of these sketches. So enhancing static art is actually, I think, pretty easy. One of the ways you can do that is by adding a lot of more configurations. So I think I may have showed this earlier, but this is like basically the polka dots example, but we're adding a lot more iterations to that. So we have different versions. So instead of just a polka dot, we have like an entire another circle around that. We have like these kind of fishes that wrap around the circle, and then different like lines that poke out. So these are like different things you can do to enhance the existing sketches that you have. You could also try adding animations. So for example, what if like these started rotating, and usually adding any kind of complexity, whether that be time or just like different types of colors or radiuses, any type of complexity, randomness, it doesn't really matter. That'll help enhance static art. You could also try and make certain things interactive. For example, have them respond to your mouse and maybe have your mouse exert certain forces on the types of or that's on the art that you have. So where can you go next? I think the very first thing you want to do is really just practice and get used to using P5 if that's something that you're interested in using. It's also probably pretty helpful to get a better grasp on color and hierarchy. I know that a lot of people probably don't really care about that, especially because like we're just randomly generating like color palettes. Like we don't even like make those colors ourselves. We're just like using fetch colors to do that. But understanding color and hierarchy might give you a better sense of structure for your sketches. For example, maybe you want to, I think I'm going to go back to the previous slide, but maybe you want to have some of these things smaller than others so you can convey a sense of, let's say like you want to make a pyramid or something. So you want to, changing certain things in your sketches will help you not only in the sketch world where you can sort of make certain things, but it'll also help you with other aspects of web development, let's say. So getting a better grasp on color and hierarchy is like pretty key in building sketches that are not only random but also structured. You could also try replicating actual algorithms from other generative artists. So the things that I showed you here are kind of just random things that I discovered, but I guess famous generative artists have like their own algorithms that they post, and you might be interested in learning those so you can make and replicate some of the effects that they make. Uh, I think for extra reading, you might want to consider reading The Nature of Code, which is like a fantastic book that teaches you how you can model physics in processing. So Daniel Schiffman, who wrote this book, didn't really have creative coding in mind while you made it, but you can just sort of use that as a foundation. And beyond 2D, obviously there's 3D. So on the right here, I just have a very simple sketch where I basically rendered out this 3D image based on depth map information. So it kind of like makes these lines. It makes the image as if it was 3D. And this is like the next step from 2D. I kind of obviously, but you can
That's
see that I'm
very
using
cool.
processing. Yeah, I'm using processing in this example, but processing is not very performant at rendering all these lines. And that's why you need to consider using something more advanced like shaders. So I just want to conclude my talk on where you can go next. But thank you all for coming out again to listen to me ramble on creative coding, and I hope you learned something. If you want to see any of these sketches, just go to my profile, and you should be able to just look at them and play with them. I'll also just post them to the community. But yeah, I hope you enjoyed.
Thank you so much, Nathan. This was wonderful. I learned so much, and I think if people in the chat did too. A lot of people were following along too, which is awesome. I will post the links to your published repls in the description of this YouTube video as well, so that people can play with them, remix them, fork them. I think everyone will have a lot of fun doing that. Thank you so much, Nathan. It's great having you.
Thanks.
Bye, everyone. Enjoy today's prompt.